Hello, so we're going to continue along the theme of expanding and simplifying algebraic fractions, except we're going to look at it from the perspective of multiplying and dividing, which I think is a lot easier than adding and subtracting because you don't need to faff around with common denominators. You just do exactly what you think you should. So for example, if I give you m over 16 times by m over 12, you just multiply across the numerators, which makes m squared. And then you multiply across the denominators, 16 times 12, which makes, well, 16 times 10 is 160, and 16 times 2 is 32, which means that together it should make 192, if my maths is correct. So m squared over 192. Now this one, you just need to be careful here because I'm multiplying the entirety of 6x plus 3 by 12, right? So I'm just going to write it as a single bracket. So I've got 12 multiplied by 6x plus 3. And denominator, well look, I'm going to multiply the entirety of 2x plus 1 by 8. So I'm going to have 8 multiplied by 2x plus 1. Now just as a little trick here, because you're multiplying on the numerators, you can cancel stuff off with the denominators. For example, I'm looking at this 12 and 8, and imagine if that was just 12 eighths, what would I simplify that to? Well, I think I'd simplify that to 3 over 2. Right, because 4 is in common to both of them, so 4 goes into 12 3 times, and denominator 4 goes into 8 twice. So I'd simplify that to 3 over 2. Okay. Then if you have a look, what I'm left with is 6x plus 3 over 2x plus 1. Well, if you kind of look at this, if I wanted to factorise this isn't fully factorised, right? Because there's a 6x plus 3, which means there's a 3 in common to both. So if you like, I'm going to write this as multiplied by 3 multiplied by 2x plus 1. Like, check it. If you expanded this out, you should get this. I've literally just factorised it. And then that's over 2x plus 1. But then if you have a look, like, I end up with 2x plus 1 over 2x plus 1. Again, because I'm multiplying, I can just cancel those off. So that would just leave me with, well, 3 times 3, which makes 9, over 2, right? So let's have a look here. A similar kind of thing. If I wanted to simplify this, I can cancel anything on the numerator with anything on the denominator because I'm multiplying. If I wasn't multiplying, if I was adding or subtracting, you need to be a bit more careful. But because I'm multiplying, it's totally fine. So for example, I'm seeing this x plus 1, I'm seeing this x plus 1 and this x plus 1, and they cancel each other off. So there's no x plus 1s anymore. Likewise, I'm also looking here and I'm seeing this 16 and this 8. Well, that goes in twice and that goes in once. Like 8 goes into 16 twice. So in total, what I end up with is 3 times 2, which makes 6, over 1 times 5, which is 5. So this is 6/5. Now, if I have a look at this one, remember when I divide fractions, I flip the second one upside down and I multiply. So it's like multiplying by the reciprocal. So I end up with 3m over 8 multiplied by, well, 15m over 20 flipped upside down makes 20 over 15m. And then if I simplify this, we'll have a look. Anything on the numerator can be cancelled with anything on the denominator. So I end up with 3m here, and that goes in there. So the m's are disappeared. The 3 and the 15 cancels to 1 and 5. And again, the 20 and the 8 I can cancel as well. So the 20 and the 8, that goes in, they both go into 4. So that goes twice, and that goes 5 times, okay? And if you have a look again, I have the 5 and the 5, which also cancels, which means I'm just left with 1 over 2, okay? If you have a look at this one then, so I multiply by the reciprocal, so 6pq over 5 times by 7 over 12p. Now, if you don't like my cancellation method, then just simply multiply them all together and then do the cancellation last. So 6pq times 7 makes 42pq. And denominator, 5 times 12p, well, that makes 60p. And then I just cancel now. So, okay, the p's and the p's are gone. Okay, so I'm just left with 42q over 60. But then I can cancel more. I've got 42 in my 60, which goes 21 over 30. Yeah, or I can divide by 3, which makes 7 over 10. So it becomes in total 7q over 10. And that's that. Now this one here is a little bit more awkward because I've got like fractions on top of fractions. So the easiest way to deal with this is to write my biggest fraction as a divide. In other words, I have this entire numerator, m plus 1. I'm going to put the brackets in now because I suspect it might help. Over 2. Subtract m minus 1 over 3. Okay. All divided by, so I'm going to write one big set of brackets there, all divided by m plus 1 over 5. Okay, and I'm going to put brackets around that. So I'm literally saying it's this numerator divided by this denominator here. Okay. Right, okay, so let's have a look at this. Well, okay, first things first, I'm going to write this as a multiplied by 5 over m plus 1. So I'll still end up with the same thing, m plus 1 over 2, subtract m minus 1 over 3, okay? Make sure it's all being multiplied. Okay, so I've changed it into a multiplication, which is going to be easier. Now here, I can make my life a little bit easier by collecting this together into one fraction. So if I collect it together into one fraction, I'm looking for a common denominator of 2 and 3. I think 6 will work. So I'm going to go for over 6 and this for over 6. Ignore this bit for the time being. So I'm literally just looking at this bit inside here. Okay, I'm looking for over 6. Well, okay, what have I multiplied this first fraction by? I must have multiplied by 3, which means that I must end up with 3 multiplied by m plus 1 on the numerator. And if I have a look here, well, what have I multiplied this second fraction by? I must have multiplied by 2. Okay, so I must end up with 2 multiplied by m minus 1 on the numerator. Again, if I'm going to collect this together, this will give me over 6. And then if I expand this out at the same time, just be careful. So I end up with 3 multiplied by m, which makes 3m. And then 3 multiplied by positive 1, which makes positive 3. And then likewise, if I expand, remember the entirety of negative 2 by m, which makes negative 2m. And then negative 2 times negative 1 gives me positive 2. Okay, and then I just simplify this down. So I end up with 3m take away m, sorry, 2m, which just leaves me with positive m. Positive 3, positive 2, that makes plus 5, all over 6. So when I piece this back together, this thing here is simply just this thing here inside the brackets. So what I end up with, if I just put it up here, because I'm running out of space, I end up with m plus 5 over 6 multiplied by 5 over m plus 1. Okay. Right, okay, so therefore in total, just multiply across the tops, multiply across the bottoms. So I end up with 5, well 5 multiplied by m plus 5, remember it's the entirety of m plus 5, I end up with 5m plus 25. I've just expanded that out in my head, all right? Then denominator, the 6 multiplied by the entirety of m plus 1 gives me 6m plus 6. Now the temptation here would be to cancel m and m there. Remember, you can't do that because you're not multiplying. If you're not multiplying, you can't do that, okay?